Hi everyone, the following is a video demonstration for how to use a dial caliper. Now the first thing to know about a dial caliper is that it uses decimal inches, which is different than a ruler, which we just covered in class, which is fractional inches. So here on what they call the blade, which is this entire length, we have just over 6 inches worth of area that we can use to measure objects very precisely, down to the thousandth or even 10,000th of an inch. So it's a precision measurement tool. How to read. In order to open this device, your hand can be placed on the wheel here, which allows you to rotate these gears inside of the dial caliper. I actually got a chance to take one of these apart once in order to fix it, and they're really interesting how they operate. It's rack and pinion. So basically there's an axle that's attached to this needle. Underneath there is a gear. That gear then meshes with this straight linear track of teeth, which they call a rack. And so it's a rack and pinion type of setup. And that's what allows us to create rotary motion and turn that into linear motion. So on here, you're going to have starting down at 0 and counts to 10. Let me focus my video. There we go. So it'll count from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you'll notice there's a 1, and it's like kind of on the upper part of that blade there. So that number right there is 1 full inch. So 1 full inch. At this point, let's see if I can get it without shaking the camera too much. Right there. 1 inch. And so as you're measuring, you look at the blade for the first 2 numbers in your value. It's the value that comes before the decimal point and the value that comes after the decimal point. So as I'm rolling on the wheel here, I could say as I'm making a measurement that this is 0.1. As I make a full rotation, you'll notice the needle comes back to 0 at the top. That would be 0.1 of an inch. And then I go another full rotation on the wheel. That's 0.2 of an inch if I'm right at 0. And then it becomes 0.3 of an inch. Now notice, as I'm rotating the wheel, the value on the blade is actually going to become visible before you actually make a full rotation and reach the next level, which is 0.4 of an inch. So that's one thing to remember as you're reading your values then. Just because you see the number 4, if I drop my dial back underneath 0, you're still in the 0.3 range. So this would actually be 0.36. And then if I move that needle around, I can get to the 10,000th number and put it at like 2 or 3 there, even in between. And that would allow you to even estimate a value beyond that. So again, let's keep rolling. 0.4 when I hit the 0, 0.5, 0.6, 0.7, 0.8, 0.9, and then one more full rotation when I get to the top here at 0. If I can dial that in. That would be 1 full inch. So you now have reached the one that's on the top of the blade, not on the bottom, the series of numbers that are all imprinted there. 1 full inch. And then as you keep rolling, it becomes 1.1 full rotation, 1.2 full rotation, and just continues its way down the blade there. So let me just come up with a random number and see what we can read it as. So I'm going to stop right there. Actually turned out pretty good on the 50. So let's see the blade. I would say that this is 1 inch and 1.7495. I could estimate that many values based off the dial there. That needle is kind of splitting the very last digit between 49 and 50. So I would call that 495. So really awesome tool to use and create different types of measurements. That's how to read the dial caliper. Now this device can actually be used in 4 different types of ways. So let's go ahead and cover those next. This is a 3D printed item that I designed specifically for this activity that allows you to do all of the 4 types of measurements. So starting with an outside measurement, you would want to place the object towards the bottom of these jaws. Don't jam it up against the blade because you're not going to get a real accurate measurement that way. So you want to drop the block down. And what I like to do is open and close the dial a few times and see where those values land Again, this is a very precise device, so getting the same value can be finicky at times. So I do a little bit of tapping here, and then I go ahead and read the value. So I would say that that was 1.509 inches. The second way to use this is with these upper jaws, which are very sharp, so please be careful as you're using this tool. I can use these to get an interior dimension. So that was called outside measurement. This is inside measurement. And I have a hole on here. And let's say I wanted to know what was the diameter of that hole. Well, I could take these jaws, insert them. Again, don't jam it inside there. Use the very tip of those edges. Rotate that out and do the same thing. Kind of tap it a few times, see where the needle lands, and then take that very best value that you can come up with and try to read it. So I would say that that is 0.492, if I'm being generous, just a little bit more of a nudge towards that needle there. Okay, so that's outside and inside. On the back here, this is the trickiest one. It's kind of awkward to do. Between these two surfaces of the dial caliper that move back and forth, you can also use that to take a step measurement, S-T-E-P, a step measurement. And so I actually have like a little stair step on this 3D printed item. And so if I wanted to know what is that height difference between the two, I could take those edges and tap them like this to get the measurement, check the dial, and read it. So I would say that's 0.261. 0.261. And then the final way is actually called the depth finder. So as you roll down on the wheel here, this part is becoming extended, and you can use this to figure out like how deep that hole is. So if I set this to inside the hole, make contact with the base of the hole, you then have to shorten the dial caliper, and I basically just brought it right to the edge on the base of the dial caliper here. And so that measurement of the hole would be 1 inch, and I would say 0.095. So that is the 4 different types of measurements that you can make. Outside, inside, on the back here is step, and then on the end is depth. So for this activity, I would like you to now find objects within your home that would allow you to make these types of measurements. Try your very best to come up with that value, and then go ahead and fill in the worksheet for this activity. And I would like you to include a picture of the object that you measured, or being measured would be even greater. So something like this, for example, just like I showed you in the demo video. If you could take a picture like that, it would be great. That way I can see how you use the dial caliper and try to read the measurement itself. And then if you could actually provide a picture of the dial caliper itself with that measurement up close like this, that would give me a better view of it. And then lastly, you take your interpretation of that measurement and type it into the last column on the worksheet for your recorded measurements. All right, there is one more thing I forgot to talk about at the beginning of this video, and that's actually how to calibrate this measurement tool. I kind of took for granted the fact that I actually have mine in calibration already because I use it pretty frequently with different projects that I'm working on. And so you'll see here that when my dial caliper is closed, the needle always returns to 0. Well, over time, as it gets used, some of these dials, there's 2 different screws here, actually get a little bit loose and it can get out of position. Especially brand new out of the box, there's no guarantee that it's going to be calibrated, ready to use. So in order to calibrate the needle down to 0, that's going to be this bottom screw, which if you loosen it, would allow you to then rotate this dial back and forth. So it doesn't matter if your needle sticks down when it's closed or if it's to the side. Sometimes I've seen that. It just kind of happens to be based on the position of that rack and pinion system behind it. Mine is facing 12 o'clock, as I would call it, so I guess I'm kind of lucky in that regard. But again, you can rotate it, make sure you're closed all the way, line it right up on 0, and then make sure you tighten that screw again so it'll maintain that position for you moving forward. Now there's one more screw at the top here, and that's actually to lock in a measurement. So let's say you were working on an assembly line and we had a bunch of these parts running through. You might be doing quality control, checking the measurements and making sure that the machine is making the part correctly. So you could take a measurement like that, that's calibrated, lock it in with this screw on the top, and then you're not really able to open and close this anymore. So again, if you were on assembly line, you could take those off, check your measurement, make sure things are working, grab another one, pass it on, and that way you're doing some quality control. So that was the overview of how to use a dial caliper. Hope you enjoyed. See you next time.